Section 15.5, Calculating Equilibrium Constants. One of the first tasks confronting Haber when he approached the problem of ammonia synthesis was finding the magnitude of the equilibrium constant for the synthesis of ammonia at various temperatures. If the value of K for equation 15.6 was very small, the amount of ammonia in the equilibrium mixture would be relatively small relative to amounts of nitrogen and hydrogen. That is, if the equilibrium lies too far to the left, it would be impossible to develop a satisfactory synthesis process for ammonia. Haber and his co-workers therefore evaluated the equilibrium constants for this reaction at various temperatures. The method they employed is analogous to that described in constructing Table 15.1. They started with various mixtures of nitrogen, hydrogen, and ammonia, allowed the mixtures to achieve equilibrium at specific temperature, and measured the concentrations of all three gases at equilibrium. Because the equilibrium concentrations of all products and reactants were known, the equilibrium constant could be calculated directly from the equilibrium constant expression. We often do not know the equilibrium concentrations of all chemical species in the equilibrium mixture. If we know the equilibrium concentration of at least one species, however, we can generally use stoichiometry of the reaction to deduce the equilibrium concentration of the others. The following steps outline the procedure we'll use to do this. 1. Tabulate all known initial equilibrium concentrations of the species that appear in the equilibrium constant expression. 2. For those species for which both the initial and equilibrium concentrations are known, calculate the change in concentration that occurs as the system reaches equilibrium. 3. Use the stoichiometry of the reaction, that is, use the coefficients in the balanced chemical equation to calculate the changes in concentration for all of the other species in equilibrium. And 4. From the initial concentrations and the changes in concentration, calculate the equilibrium concentrations. These are then used to evaluate the equilibrium constant.